This video is dedicated to the processing of the mandatory parameters table, which is an input table enabling to enter the main surface parameters of an optical system in the advanced calculations tool. Before watching this video, it is preferable to have first watched the quick start video. The mandatory parameters table is displayed in the surface parameters page, which is accessible from any page of the advanced calculation tool by clicking on the surface parameters link in the input menu. The page proposes 4 tables, including the mandatory parameters one. These tables appear after clicking on their title. First of all, note that the entered parameters are saved only if the user has clicked on the Save button of the concerned table. For instance, if I enter a value in the mandatory parameters table, and if I click then on the Save button of another input table, you can see that the value has not been saved. Among the proposed table, the mandatory parameters one must absolutely be completed. In this table, the basic parameters of your optical system are defined. Each surface is specified by a number, or by obj for the object surface, or obs for the observation surface. R is the radius of curvature. N is the refraction index of the medium after the surface. V is the constringence of the medium after the surface. Lowercase d is the distance to the next surface. Uppercase D is the surface diameter. Type enables to select a type of surface. V paraxial is the paraxial constringence. This cell is only activated if the surface is a paraxial one and not a real one. I will come back later on it. Aperture allows to define an eventual aperture or obturation on the surface, and tilt decenter specifies if the surface is eventually tilted or decentered regarding the precedent one. Here are some rules for entering parameters in the mandatory parameters table. The radius of curvature R is either a number or infinite if the surface is plane, like surface 8 in the present case. For a refracting surface, the refraction index n can be either a number or a glass catalog reference. The glass catalog references are available in the catalogs page of the handy calculations tool. For a reflective surface, the refraction index n is equal to mirror. Note that the object surface can never be reflective. More details are provided in the tutorial associated to this input table, but the following rules are always valid. For a given surface, if n is a number, v is also a number or infinite if the medium is not dispersive like air or vacuum. If n is a glass reference, v must be the same reference. For instance, if the refraction index is defined by the reference n-bk7, like for surface 2, the constringence must also be defined by n-bk7. For a reflective surface, n is defined by mirror, and v is the same as that of the previous surface. Lowercase d is the distance to the next surface. It is in general a number. Its value on the object line can also be infinite if the object is at infinity. For all other surfaces, it is necessary a number. Note that the distance from a reflective surface to the next one has the opposite sign to that of the distance to it. This rule applies only if the following surface is not the observation surface, in which case the sign can be chosen freely. The type cell defines the type of surface. If the selected type is not spherical, extra parameters have to be specified in the non-spherical surfaces table. The relevant cells are then activated in this table. If, for instance, a surface is aspheric, as surface number 7, the cells corresponding to the conicity and asphericity parameters are then activated in the non-spherical surface table and have to be filled. The V-paraxial cell is in general disabled, except if the surface type is thin lens or thin lens XY. These two types of surfaces are ideal lenses. For thin lens, rays propagate according to the paraxial propagation laws of thin lenses. For thin lens XY, the rays projections in the XZ and YZ planes propagate according to the paraxial propagation laws of thin lenses, but with dedicated focal length in each plane. The V-paraxial parameter is the constringence of the lens. It can be defined by a glass reference, by a number, or by infinite if it is considered that the lens is not dispersive. It is the case here of the first surface. Note that if thin lens or thin lens XY is selected, the media before and after the lens must be air or vacuum, which means that the refraction index and constringence before and after the surface are respectively 1 and infinite. The aperture cell defines if the surface eventually includes an aperture or an obturation and its type. If an aperture type other than known is selected, like for surface 5, extra parameters have to be entered in the links and obturations table for the surface. For instance, if a rectangular obturation is selected, it means that the aperture has a rectangular shape inside which the rays are blocked by a smaller rectangle. The dimensions of these rectangles across the X and Y axis have to be defined in the links and obturations table. Finally, the tilt and decenter cell defines if the surface is tilted or decentered regarding the previous one. If yes is selected, extra parameters defining the relative tilts and decenters of the surface must be specified in the tilt and decenters table. Keep in mind that this video is a short presentation and that more details are provided in the tutorial pages relative to the input tables of this page. Thank you for your attention.